chest. It's the volume of air your lung can move from maximal to minimal volume. Vital, life, vita, life. It's the capacity you have to live with. Vital capacity. Is this a capacity or a volume?
Capacity.
Capacity. And it's the total lung capacity. So this is memorization. I tried to make it make some sense in terms of understanding. Well, okay, get you. If you know what the difference between a volume and a capacity is, you're a part of the way there. If you know which is, this is inspiration and this is expiration, you're part of the way there. But you have to just memorize tidal volume, vital capacity. Some of them are just names, but some of them have names that make sense. So here's the answer key. So make sure that your handout has the same names as the book. Here are some representative values, typicals. I will not expect you to know everything, but I do expect you to know an approximate value for tidal volume. So a normal inspiration, expiration, a normal tidal volume, not exercising, not stressed, not teaching, because I'm stressing my respiratory system big time right now. But your tidal volume is on the order of 500 mils. But there's a big variable from person to person. 400 might be normal for you, 600 might be normal for you. 500 is a typical normal value. I do want you to know that, because I might ask you to actually use some numbers. And knowing a reasonable number to start with is something to know. 500 mils. Vital capacity. From maximum expiration to maximum inspiration. So the volume starting now, the volume I just inhaled, typically 5 liters. 4.7 liters, 5.5 liters, depends on the size of the person. So 500 mils for a tidal volume, 5,000 mils for a vital capacity, and total lung capacity on the order of 6,000 milliliters. Your book calls it 4.7 liters and 5.9 liters, but you can round it up. 0.556 liters, or 500 mils, 5,000 milliliters, 6,000 milliliters. Know those values. If in a problem you use 5,000 milliliters here, fine. But if you use 500 milliliters here, not fine. Questions? Okay, so let's end. We're close to the end for today. With this definition of dead space. So when you move air, this is supposed to illustrate the tidal volume. You're moving 500 mils of air from the air into your lungs. Some of it is getting to your alveoli, where there's gas exchange. But some of it is stuck in your conducting airway, where remember the trachea, the bronchi, the bronchioles, the conducting airway has volume. So each time you breathe, some of it does gas exchange, and some of it doesn't. And this is called the dead space. It's not dead. I mean, it's a really harsh name for air that you inhale that doesn't do gas exchange. It doesn't participate in gas exchange. You move 500 mils in, and only 350 mils of it participates in gas exchange, and 150 mils or 100 or 125 or 160, depending on the person, goes in, but then goes out without having participated with for gases. It's the dead space. So in the problem set, you're going to be using some of these typical values to calculate some other things, but I think I have not given you, so we're going to start on Wednesday with the key equations that you'll need to work on the problem set. So given the time, I could move ahead into the material that I had planned for Wednesday, but I think I would rather not. I think I would rather stop early. I mean, there's a couple of clickers. Let's do a couple of clickers and then call it a day. Wednesday is going to be a big day because we're going to be using some equations, but we'll be building on this. So I'm just giving you a heads up. You might want to read the book or prepare for Wednesday's class. I still think we can do it in the 2 hours that are allocated to it for lecture, plus an hour or so of transport and breakout. Okay, let's do this as a traditional clicker. Let's do this together. Which of the following are true? Let's do it as a traditional clicker. Show me your answers. Okay, good. I'm seeing a lot of the correct answers. They're all true. They're all true statements. Any questions about those? Okay, which of the following are true? Go ahead and read them, answer them, and show me your answers. This one's a little harder. They're all true. The one that's trickiest is D. So let me show you what I mean by that, because this is important when we do a clinical case. Here is an airway. Here is intrapleural pressure. Negative intrapleural pressure tends to hold these flimsy little airways open. Just like negative intrapleural pressure holds the flimsiest of the structures, the alveoli, open, negative intrapleural pressure tends to hold flimsy, bronchioles open. So during expiration, less negative intrapleural pressure tends to collapse airways. And inspiration, expiration, less negative intrapleural pressure tends to collapse airways. Inspiration, large negative intrapleural pressure tends to open airways. Those of you who know someone with asthma may have heard that they find when they're having an asthma attack, they find it easier to inhale than to exhale. Because during an asthma attack, airways are constricted, and the constriction of airway in asthma is exacerbated by expiration and is ameliorated or improved during inspiration, right? The airways are constricted, more constricted during expiration, less constricted during inspiration. They can breathe in more easily than they can breathe out. Asthma attack. So that's why this is a true statement. Any other questions about this one? This is just Ohm's law. The diameter controls the resistance. That's it. So let's call it a day. The PowerPoint from today will be loaded up with answers. The PowerPoints for today will be loaded up with answers. The PowerPoints for Wednesday are loaded up without answers. I recommend, looking at the text, reviewing the textbook, get the concepts you get, and get confused about the concepts you don't get. Look at the PowerPoint, and you'll see where we're going to go on Wednesday. We're going to finish the respiratory system on Wednesday, okay? And then do lab, and then exam on cardiovascular and respiratory on Monday.